Hey, hello to the Web3 community. We are submitting our project for the Polygon hackathon. Our name is Prathamesh, Itiksha, and Darpit. And this is our entry named Sententia for the Polygon hackathon in the track of public goods and everything zero. So to start with, before getting into what we are building and how we are building, let's get a step back and try to see that why we are trying to build this. So we three had always believed in trying to contribute more towards the Web3 space and towards the idea of decentralization uh, by using blockchain technology. And we realized that while understanding the governance of DAOs, even though it is taking place at a decentralized level, it is completely relying on a centralized voting system, which seemed pretty ironical. I would be explaining a bit about that too. So before that, let me summarize a bit about what we are trying to exactly build. So Sententia is trying to make an off-chain vote counting system reliable and trustworthy without having any third party acting as a central point of failure. So users generally generate a proof of vote for the options voted. The count of the proof of vote will lead to transparent and backtrackable calculations of the final results. The proof of votes would be encrypted with only voters having the power to decrypt it. The third party will fail to tamper with the votes and hence the results in an off-chain voting system. So we are trying to build an off-chain voting system which is reliable and trustworthy and doesn't have a central point of failure. What does proof of vote mean here? Proof of vote is a ZK proof of someone who has voted for some action, but who has voted is being hidden and it is being a private input. So, what was the problem which motivated us to get into this? So, generally, the voting system it comprises of two systems. One is on-chain voting and one is off-chain voting. Most of the protocols they avoid on-chain voting because of the gas fees which is required in the entire voting process. So, most of the protocols they rely only on off-chain voting, and the industry standard which is being used is snapshot. So, what are some issues or like what are some assumptions which the option which the protocols are taking while relying on off-chain voting? So they are being trusted heavily while collecting the votes and while final competition. So there is a lot amount of scope for any protocol for any third party to tamper the votes which are being collected and even the final computation. Also, the votes, like who has voted to whom, the complete access of this information is given to the third party. Currently, even this information is available to all the voters, even during the proposal, which can lead to bribery and corruption. If I know that I would be voting for someone and I can prove it to some person, I can take money for that or some crypto for that. So we designed or created a problem statement for ourselves. It was like enable an off-chain voting system where the calculation of final votes is verifiable and who has voted for whom is not known to anyone, including even the third party who is computing. So this was a problem statement which we chose for ourselves, and it was pretty interesting. The overall journey to try to brainstorm that how we would be catering to this problem. So we tried to, at a high level, divide the solution into three parts. First, there is going to be a section where a voter has cast a vote is publicly known and this is verifiable. The person who he has voted for or she has voted for that is not known, but this is known that a voter who is a legible voter who has some governance token has voted and this is publicly known and verifiable. The second, there would be pool of votes which are derived only from the voters who had voted in this protocol. These cannot be mapped and that we can't know that who had voted for whom. Hence, this can avoid any tamper or manipulation by any party, and the calculations which of the votes are being done, they are trusted and they are verified. So how can we link these two things? There needs to be a trusty black box in the middle, and we believe that proof of vote, which is like inspired from ZK proof, and encryption can be that trustworthy black box. So this is just a demonstration and illustration of how it is like what on a meta level the solution look like. So let's get into the nitty gritties. Initially, I will help you with the initiation of a proposal flow and try to tell you that how that takes place. So there is a person who has some valid governance token in his wallet. The person would be able to initiate a proposal. Once the proposal is initiated, the information about the proposal, which comprises of the title, description, option, start date, and date, wallet address of the initiator, is stored on IPFS. So this is how it does. There is some verification process. So I will show a demonstration of this from our Sententia website. So here is a Sententia website making voting better. Let's get started. Let's try to see. Let's try to create a um, proposal for Aave. Yeah. So here is a new proposal. Um, for the demonstration purpose, let the title be demo. Let the description be demo. Let there be a start date. Let there be some end date, and let there some voting type. So we are currently supporting linear voting and quadratic voting. Add proposal. So now in the backend, there would be the backend would be verifying if the person who is initiating the proposal is he having the tokens to do so. This is the MetaMask wallet which is opening. I'm confirming it, creating proposal. So here keys would be generated for the proposal, and then the proposal is being fetched. So a proposal is created. Yes, here it is. We can see it. Here are two options: agree and disagree. And we can this check result is just for demonstration purpose, but we won't be having it afterwards. Yeah. So this is how the initiation of a proposal takes place. Now let's talk about the process, the most interesting process, which is about how the voting on a proposal takes place and how those are calculated. So a voter, he would be generating a proof of vote, which he would be encrypting, and the encryption is only available with all the voters who have a governance token. The encryption pair is deterministically and randomly generated by the proposal title, description, and timestamp of the proposition. These are taken as an input, and a key pair is generated. The key pair is for all voters, and the access of it won't be with the third party. The proof of generated the proof of work needs to be generated from the end of the user and not on the backend. If it is being generated at the backend, then the third party would be able to tamper to it. So currently, the proof of work is being generated in the command prompt and being uploaded because we tried to generate it on the browser, but we needed to learn it about. And in our next steps of roadmap, we would be definitely having that. Once the encrypted proof of vote is uploaded by the user on a site, it would be streamlined to the backend and saved based on whichever option they belong to. So the proof of vote, there are two categories of proof of vote. One would be for option A, the second would be for option B, and they would be encrypted. We won't be knowing who has submitted it. So that is the thing. And once they are encrypted, we won't be able to make any changes or even create a duplicate one. The hash of the proofs, they would be stored on a smart contract on Polygon. The list of the voters who have voted is also maintained on a separate smart contract. Note here, the option which they have voted to is not known to anybody. Once the proposal time is over, the proof of vote will also be uploaded on IPFS. Any voter after that can paste the private key to see the results. So once they use the private key and try to verify that whether the computation done by us of the proof of votes is equivalent to the one which are there on IPFS. So this is how we are trying to make ensure that any third party, even us who are trying to compute the results, will not be able to add, delete, or change votes of any voter, and also not hence be able to change the final counting done by third party. So this is the flow of how it takes place. So how does this process help? This process will help us ensure that the proof of vote is maintained on a smart contract without being revealed who has voted for it. The total number of proof of votes for each option will help us get the end result, and there is encryption to make sure that no third party can imitate those proof of vote. We also have a roadmap trying to cater to the edge cases which we would be like know that there are present. Apart from that, we are also trying to cater to other problems. Just a quick demonstration on how the voting takes place. Uh, if I click on agree and then I click on OK and I confirm. So they are checking my voting status to make sure that we are not doing any double voting. Hence, here we can check our results. So here I had voted for one agree, and here is a list of proofs. So yes, thank you for this. We are looking forward to build this project ahead and try to expand it as much as possible. Thank you.